Hi, in this video, I'm going to present my paper on the preference for wealth and inequality towards the Piketty theory of wealth inequality. This is joint work with my co-authors in Japan, Yoshiyasu Ono and Matthias Schlegl. Let me begin with a quotation from Keynes in 1919. The immense accumulations of fixed capital, which, to the great benefit of mankind, were built up during the half-century before the war, before World War I, could never have come about in a society where wealth was divided equitably. In other words, according to Keynes, wealth inequality is necessary for capital accumulation. Let's keep that in mind. So this is a paper on wealth inequality. There are a few well-established facts about wealth inequality. First, the distribution of wealth is highly unequal with a thick upper tail. The saving rate is strongly increasing in wealth. And finally, a closely related fact is that wealthy households consume much less than their permanent income. Now, these stylized facts are inconsistent with the neoclassical growth model. It appears that the desire to accumulate wealth or to leave bequests is a key driver of the saving behavior of the rich. And so the question that we want to address in this paper is the following. What is the impact of the preference for wealth on the dynamics of wealth inequality? So let me give you the outline of this presentation. First, I'm going to present the model. This is just simply the neoclassical growth model with a preference for wealth. Then I'm going to show some partial equilibrium results. And by partial equilibrium, I mean with a fixed capital stock, a fixed wage rate, and a fixed interest rate. And I'm going to show that wealth inequality rises whenever the interest rate is larger than the growth rate of the economy, and wealth inequality falls whenever the interest rate is smaller than the growth rate of the economy. This tightly corresponds to the Piketty theory of wealth inequality. Then we're going to endogenize the capital stock, the wage rate, the interest rate, and derive some general equilibrium results. We're going to show that the economy either converges towards an inegalitarian steady state or towards an egalitarian steady state. Finally, we introduce shocks to the preference for wealth and rely on numerical simulation to investigate three policy experiments: a wealth levy, a progressive wealth tax, and a progressive consumption tax. Now, I'm not going to do justice to the literature on wealth inequality, but I want to emphasize that our work is related to a large quantitative macro literature that tries to account for the thickness of the upper tail of the wealth distribution. And basically, there have been four explanations that have been provided that are provided to account for the thickness of this upper tail of the wealth distribution. First, the bequest motive. This is the idea that parents derive utility from leaving a large estate, a large amount of wealth to their children. Well, that's literally the preference for wealth. A second line of explanation is heterogeneity in discount rates. Some households and some dynasties are more patient than others and end up accumulating much more wealth. Well, the preference for wealth endogenizes the heterogeneity in discount rates, with wealthy households becoming endogenously more patient than others, which is a key driver of wealth inequality. A third line of explanation is stochastic aging. The idea is that households will live for very long, have more time to accumulate a large fortune. Well, again, this is closely related to our analysis, because when we introduce shocks to the preference for wealth, then dynasties that manage to retain the preference for wealth for longer end up accumulating more wealth than dynasties that lose the preference for wealth quite rapidly. Finally, a fourth line of explanation for the thickness of the upper tail of the wealth distribution is heterogeneity in rates of return. Well, this is completely absent from our analysis. Now, my guess is that allowing for heterogeneity in rates of return would probably strengthen our policy conclusions, but this is beyond the scope of this analysis. So let me start by showing the model. So the model is embarrassingly simple. It's a neoclassical growth model with a preference for wealth. Let's dive in. So time is continuous. There's a unit mass of household with population size capital N growing at rate little n, and labor productivity capital G growing at rate little g. Therefore, output GDP will grow at rate G plus N. We assume a neoclassical production function with constant returns to scale, which implies that output per efficiency unit of labor is an increasing concave function of capital per efficiency unit of labor, which we're going to denote by little k. Now, this implies that each factor in equilibrium is going to be paid its marginal product the interest rate is equal to the marginal product of capital, net of depreciation, and the wage rate is equal to the marginal product of labor. Just WT is the wage rate relative to labor productivity, such as to make the variable constant over time. Now, households. We have a continuum of mass 1 of infinitely lived household. So each household should be interpreted as a dynasty. Households are going to be indexed by I, running from 0 to 1. Each household has consumption little c per efficiency unit of labor, has wealth little a per efficiency unit of labor, and more importantly, the household derives utility from both consumption and wealth. More specifically, households care about consumption per capita. Consumption per capita is consumption per efficiency unit of labor multiplied by labor productivity. Households care about wealth per capita relative to productivity. That means wealth per efficiency unit of labor. The idea is that if productivity is twice as high, then a given amount of wealth only seems to be half as large from the perspective of the utility that households derive from the ownership of this wealth. Now, it may sound more natural to assume that households care about wealth per capita relative to output per capita, or wealth per capita relative to average wealth per capita, but this would introduce an externality from wealth accumulation, which we prefer to avoid. Now, the preferences that we assume is given by this balanced growth specification. So we have a constant elasticity utility of consumption, we have a concave utility of wealth, and we have the scaling factor to ensure balanced growth. Now, in fact, this is the only specification that is consistent with additively separable preferences between consumption and wealth, with the absence of externality from wealth accumulation, and with balanced growth. If we don't have heterogeneity in the economy with under representative agent, this specification ensures that there exists a balanced growth path. And this specification is also used by Mian, Straub, and Sufi in their recent analysis of fiscal policy. Now, what about the specification of the preference for wealth? Well, the preference for wealth is given by a constant elasticity specification with respect to reference point zeta, which is negative. So that's the specification of the utility from wealth. Now, the important parameter is the parameter mu, which determines the curvature of the preference for wealth. And the critical assumption we are making throughout our analysis is that mu is smaller than sigma. That means that the preference for wealth is more linear, less concave than the preference for consumption. This ensures that wealth is a luxury good, which means that as households get wealthier, their saving rate increases, which is the empirically relevant case to focus on. Now, the only source of heterogeneity across households in this economy is initial wealth, and so phi denotes the initial wealth distribution. Each household solves the following problem. So each household needs to determine its path of consumption, such as to maximize intertemporal utility, subject to the flow of funds constraint, where the flow of funds constraint gives the increase in wealth per efficiency of labor being equal to the income from capital, net of the dilution of wealth due to a growing economy, plus the income from labor, where labor supply has been normalized to 1, net of consumption. Initial wealth is given, and we impose a borrowing limit, so household wealth cannot fall below a threshold A lower bar. So where A lower bar is a non-positive number, is either 0 or negative. Now, when we solve the household problem, we end up with the consumption Euler equation together with the transversality condition. Now, whenever the borrowing constraint is not binding, the consumption Euler equation holds with equality. The first 3 terms of the consumption Euler equation are the well-known terms from the neoclassical growth model. And so what's interesting here is a new term due to the preference for wealth, which is a ratio of the marginal utility of wealth over the marginal utility of consumption. And because wealth is a luxury good, because mu is smaller than sigma, as households become wealthier, they care more about wealth accumulation, which implies that wealthy households are going to have a higher saving rate than poor households, which is going to be a major driver of wealth inequality. Finally, to close the model, we need to impose a market clearing condition. First, output must be equal to consumption plus investment, which implies a capital accumulation equation. So the increase in capital per efficiency unit of labor is equal to output net of the depreciation of capital, net of the dilution of wealth due to the growing economy, and net of aggregate consumption. We also have an asset market clearing condition which specifies that household supply of savings must be equal to firms' demand for capital. And this closes the model. So now let's derive the partial equilibrium results. So by partial equilibrium, I mean that the capital stock is fixed, the weight rate is fixed, and the interest rate is fixed. So we're going to focus on the joint dynamics of consumption and wealth at the household level. Now, going back to the flow of funds constraint, to the household's flow of funds constraint, we can actually see that two cases must be distinguished. Either R is greater than N plus G, or R is smaller than N plus G. So let's first focus on the case where the interest rate is larger than the growth rate of the economy. So this is the corresponding phase diagram. On the horizontal axis, we have wealth. On the vertical axis, we have consumption. The A dot equal to 0 line, well, that is coming from the flow of funds constraint. The slope of this line is equal to R minus N minus G, and because the interest rate here is larger than the growth rate of the economy, this A dot equal to 0 line must be upward sloping. The C dot equal to 0 line is given by the consumption Euler equation. Because wealth is a luxury good, this C dot equal to 0 line is concave. And therefore, we typically have two steady state equilibrium possibilities, a lower steady state, AS, that is locally stable, and an upper steady state, AU, that is locally unstable. Now, this implies that if initial wealth is below AU, then wealth is going to converge to the lower steady state. If initial wealth is above AU, then wealth is going to diverge to infinity. So we therefore have that, like, when R is greater than N plus G, then the market mechanism leads to rising wealth inequality. Now, we also have the opposite possibility that when R is smaller than N plus G, then the A dot equal to 0 line becomes downward sloping. And so we're left with only one steady state equilibrium possibility, which is locally stable. And so we observe that when the interest rate is smaller than the growth rate of the economy, the dynamics of wealth inequality becomes equalizing, with all households converging to the same wealth level. Now, I want to emphasize that this precisely corresponds to the narrative of the Piketty theory of wealth inequality, that when R is greater than N plus G, wealthy households only need to consume a little bit less than their permanent income to see their wealth diverge to infinity. And conversely, when R is smaller than N plus G, then the growing economy leads to a dilution of wealth that the interest rate fails to compensate, leading to like an equalization of wealth. That's exactly what's at work in this analysis. Now, general equilibrium. So what happens if we endogenize the capital stock, the weight rate, and the interest rate? Well, before going into the details, let's go back to the phase diagram when the interest rate is larger than the growth rate of the economy. We see that household whose initial wealth is above AU, their wealth diverges to infinity. But as they become wealthier and wealthier and wealthier, then this increase in the supply of saving must increase the capital stock of the economy. But as the capital stock increases, the marginal product of capital goes down, and therefore the interest rate goes down. But remember that the slope of the A dot equal to 0 line is equal to R minus N minus G. And so as wealth increases, the A dot equal to 0 line becomes flatter, and so the AU threshold increases over time. And so the inegalitarian steady state corresponds to a situation where R tends to N plus G, and the upper threshold tends to infinity. Okay, so let's see that more formally now. So first, before characterizing the equilibrium of the economy, I want to remind you of some definition, and in particular, the definition of the golden rule level of the capital stock. So that follows from the capital accumulation equation that we've derived before. And from this capital accumulation equation, we know that in steady state, aggregate consumption is equal to output net of depreciation, net of the dilution of capital due to a growing economy. Now, the golden rule level of the capital stock is defined as a capital stock that maximizes steady state consumption. And by taking a first order condition, we immediately see that the golden rule level of the capital stock is such that the marginal product of capital is equal to depreciation plus the growth rate of the economy. Now, when the capital stock is at the golden rule level, the interest rate must be equal to the growth rate of the economy. Finally, we can define the golden rule level of consumption as the aggregate level of consumption when the capital stock is at the golden rule level. Okay, with this definition in mind, we can characterize the general equilibrium possibilities of the economy. Let us first focus on the egalitarian steady state. So that's a steady state where everyone has the same consumption level, CE, and the same wealth level, KE. Well, this egalitarian steady state equilibrium always exists and is unique. But more importantly and more interestingly, this steady state equilibrium is locally stable if and only if the egalitarian interest rate, so the egalitarian interest rate is the interest rate implied by the capital stock in this egalitarian equilibrium, is sufficiently low. Okay, so the egalitarian steady state exists if and only if the capital stock is so large under wealth equality that the interest rate is so small that we can have a locally stable egalitarian steady state. So in other words, the egalitarian steady state only exists if the preference for wealth is sufficiently strong across households that even with an equal distribution of wealth, the wealth per capita is sufficiently high to have an interest rate that is sufficiently low. Now, there's an alternative equilibrium possibility, which is to have an inegalitarian steady state equilibrium. In fact, we are showing in the paper that this inegalitarian steady state can exist if and only if the egalitarian steady state, the egalitarian interest rate is above the growth rate of the economy. So in other words, if wealth equality results in a capital stock below the golden rule level and an interest rate above the growth rate of the economy, then an inegalitarian steady state equilibrium can exist. In that case, as I've just argued before, the interest rate must converge to the growth rate of the economy, so R must converge to N plus G, and the capital stock must converge to the golden rule level of K star. Now, in this equilibrium, we end up in a situation of extreme wealth inequality with a zero mass of household having arbitrarily large wealth, while all the other households either converge to the borrowing limit, a lower bar, or to the lower steady state, whichever is higher. But typically, we have ordinary households with very little wealth and the zero mass of households who are hugely wealthy. Now, what does this equilibrium, what does this inegalitarian equilibrium imply for the consumption of ordinary household? Well, when R is equal to N plus G, the consumption of ordinary household is just equal to the labor income. But labor income at the golden rule level of the capital stock, we can compute it, and it's equal to, oh surprise, it's equal to the golden rule level of consumption. And so even though we have extreme wealth inequality, we have a situation, we have a steady state situation that is very favorable to ordinary households because they end up with the golden rule level of consumption. Now, how can we explain this paradox? Well, basically, we have a zero mass of household with arbitrarily large wealth. These households have very high consumption per capita, but the total mass of their consumption is negligible relative to the size of the economy. In fact, the total mass of the consumption of the rich asymptotically tends to zero, which allows ordinary households to fully enjoy the consequences of the capital stock being at the golden rule level. Just to use an analogy, let's think about Elon Musk, Warren Buffett, and Bernard Arnault. They are the wealthiest people on earth. Their consumption per capita is surely very high, but the total mass of their consumption is negligible relative to the size of the US or the French economy. Well, that's the same idea here. Like wealthy households have very high consumption per capita, but the total mass of the consumption is negligible. So putting things together, we've established that we have a number of equilibrium possibilities depending on the value of the egalitarian interest rate. If the egalitarian interest rate is sufficiently low, then the economy must converge to the egalitarian steady state. If the egalitarian interest rate is sufficiently high, then the economy must converge to the inegalitarian steady state. And there's a range of value for the egalitarian interest rate such that the economy can either converge to the egalitarian or the inegalitarian steady state. Now, a couple of remarks are important. First, we do not have multiple equilibria. For a given initial wealth distribution, the economy either converges to the egalitarian or to the inegalitarian steady state. Second, if we have a thick upper tail of the initial wealth distribution, then the economy must converge to the inegalitarian steady state. So whenever both steady state equilibrium possibilities can exist, the inegalitarian steady state is much more plausible empirically. But if we cut the upper tail of the wealth distribution and give the wealth to ordinary household, to poor household, then we can set the economy on a path converging to the egalitarian steady state. So this shows a strong form of history dependence. Now, taking a step back, this analysis has shown that the preference for wealth only generates inequality when the capital stock is below the golden rule level. So if wealth equality results in a capital stock that is below the golden rule level, then wealth inequality is actually necessary to raise the capital stock and to bring it closer to the golden rule level, which is in line with Keynes' intuition in 1919. Conversely, if the propensity to save is sufficiently widespread that an equal distribution of wealth leads to a capital stock above the golden rule level, then in that case we have equalizing dynamics at work and wealth inequality tends to fall over time. So the market mechanism only generates wealth inequality when it's actually useful for capital accumulation. Now, one interesting finding from this research is that the preference for wealth induces the capital stock to converge to the golden rule level. Just discussed that extensively through the inegalitarian steady state. But in fact, in previous research with the same set of co-authors, we've shown that whenever an equal distribution of wealth results in a capital stock above the golden rule level and an interest rate below the growth rate of the economy, then we can have a rational bubble that brings the capital stock at the golden rule level, exactly as would be the case in an overlapping generation economy. So this shows that whether an equal distribution of wealth results in a capital stock above or below the golden rule level, the preference for wealth creates some equilibrium possibilities that can induce the capital stock to converge to the golden rule level, which I think is a pretty nice insight. Okay, so these are nice theoretical insights, but they assume that households have a preference for wealth forever, which is maybe a bit extreme. A more plausible assumption to make is that some households have a preference for wealth, others do not, and that there are shocks to the preference for wealth. Some dynasties may have the preference for wealth for a number of generations, and then at some point you could have some heirs of wealthy dynasties that lose the preference for wealth and that squander the family estates. Conversely, you can have a household that do not have the preference for wealth and that eventually acquire a preference for wealth. And so now we're going to assume that we have shocks to the preference for wealth. So more specifically, we're going to assume a two-state Poisson process. In state W, the household has a preference for wealth, and in state N, the household does not have a preference for wealth. Now, we're going to assume that about 20% of households are in state W, and 80% of households are going to be in state N. So only 20% of households at any given point in time have a preference for wealth. And the preference for wealth lasts on average for 75 years, which is about 3 generations. And this implies that not having a preference for wealth is very persistent because it lasts on average for 300 years. So then we rely on a mean field game formulation of our equilibrium in order to rely on the Ben-Moll algorithm to make numerical simulations of the equilibrium of the economy. So we need to calibrate the model. And so we rely on a pretty standard calibration. There are just a few parameters that I want to emphasize. First, the borrowing limit. So we set a 0 borrowing limit, and that can be interpreted as a no negative bequest constraint. Parents cannot leave a negative estate to their children, and the children are allowed to turn it down. So the borrowing limit is just 0 wealth. The two key parameters of the model that we need to calibrate are the curvature and the intensity of the preference for wealth. Well, these two parameters are calibrated such as to match the average wealth of the bottom 90% of the wealth distribution and the average wealth of the top 1% of the wealth distribution, as reported by Sayers and Zuckman. I should also emphasize that this calibration results in an interest rate of about 4%, while the growth rate of the economy is about 3%, which means that in our simulation, the inegalitarian dynamics are going to be at work because the interest rate is going to be larger than the growth rate of the economy. So this is some simulation outcome, and basically this is showing that our model does a pretty good job at accounting for the thickness of the upper tail of the wealth distribution. So the model-generated moments are a pretty good match for the empirical moments. Now the bold lines are like the bold moments are the one that we match. So, but the other ones we have not imposed, and so they can be seen as over-identifying restrictions. There's, however, one dimension over which our model does a poor job at matching the data. This is a share of household with zero negative wealth. In the data, you only have about 20% of household with zero negative wealth, while in our model, about 72% of household have zero wealth. Now, how can we explain this? Well, it's very simple. We just do not have any idiosyncratic shocks to labor income. But if we did introduce unemployment risk, health risk, disability risk, then household would accumulate some precautionary savings, and there would be a lot of households who, instead of having zero wealth, would probably have like 10, 20, 30, $50,000, and we're missing this small accumulation of wealth. However, I want to stress that we are matching the average wealth of the bottom 90%, which is $84,000 according to Sayers and Zuckman, and that this gap between the model and the data should have little consequences for our analysis of wealth inequality, where we're really focusing on the upper tail of the wealth distribution. So when we look at the dynamics of inequality, so we have the saving rate. So A dot, there's a saving rate of household of type W with a preference for wealth. That's always positive. So household with a preference for wealth always accumulate wealth. And the dotted line gives the saving or the accumulation of wealth for household without the preference for wealth. And we can see that households that do not have the preference for wealth tend to become poorer over time. So household of type W accumulate wealth, household of type N decumulate wealth, and that's going to be the main driver of wealth inequality in this model. The flip side of this is that, of course, household of type household of type N, who do not have the preference for wealth, have a much higher consumption level than household of type W. Let us perform a number of policy experiments. So first, let's consider the possibility of a wealth levy. So wealth levy is a surprise, one-shot, lump sum redistribution of wealth. So we impose a 20% levy above a $10 million threshold. So if your wealth is $15 million, then you have $5 million above the threshold, and the government confiscates 20% of it. So you have to pay $1 million to the government. Now, the proceeds of the wealth levy is transferred as a lump sum transfer, or is given as a lump sum transfer to household at the borrowing constraint with zero wealth. And that results in a transfer of about $22,000 for each household with zero wealth. Now, how does the economy respond to this lump sum redistribution of wealth? Well, poor households at the borrowing constraint respond to this transfer by raising the consumption level. In fact, they're going to spend the $22,000 over 5 or 6 years, pretty rapidly. Now, initially, output is just equal to F of K, and so the capital stock doesn't change, and output doesn't change. So if consumption increases, then investment must fall. But as investment falls, the capital stock shrinks, and there's a contraction in economic activity, output goes down. The decline in output raises the marginal product of capital, which increases the interest rate, and it reduces the marginal product of labor, which reduces the wage rate. Now, who gains and who loses from this policy? Well, this is the consumption equivalent welfare gain as a function of wealth. Now, the first thing we can see is that with the 2 dots at zero wealth, well, this is basically the welfare gain for households who receive the transfer. They receive the transfer and they're better off as a result. To the right, we can see that very wealthy households actually lose from the wealth levy. That's not very surprising. Some wealth has been taken away from them. They're not happy about this. But what's more interesting and more surprising is that households with wealth between $0 and $10 million were not directly affected by the wealth levy, since they neither pay the tax nor receive the transfer. They're nonetheless affected by the policy through the general equilibrium effects. In particular, households who are quite wealthy, with a wealth between, let's say, $1 and $10 million, they're actually better off thanks to the wealth levy. Why? Because the wealth levy raises the interest rate, and therefore, as wealth owner, they are better off, especially if they're of type W and they enjoy accumulating wealth. Another general equilibrium consequence of the preference for wealth, which is less visible but not less important, is that not so wealthy households lose from the policy. So household with maybe like $100, $200, $300,000, they actually lose from the policy. They're too wealthy to receive the transfer, but they actually lose from the reduction in the wage rate implied by the policy. So this is the by the lump sum redistribution of wealth. Now, to understand the effect of this policy, we need to think about, we need to go through a thought experiment. Let's imagine that we take $100 from Bernard Arnault or Warren Buffett and give this $100 to a poor person. What are the effects on the economy? Well, if you take $100 from Bernard Arnault or Warren Buffett, their income probably goes down by $7 or $8. They're pretty good investors. They may have a 7 or 8% return on investment. So if their wealth goes down by $100, then their annual income probably goes down by $7 or $8, maybe a bit more. Now, if their income goes down by $7 or $8, then their consumption will probably go down by $1, maybe even less, because they have such a high propensity to save and such a low marginal propensity to consume. Now, you give the $100 to a poor person. Well, the poor person is going to spend the $100 over a short period of time. And so what this lump sum redistribution of wealth achieves is to transform a stock of wealth into a flow of consumption. The wealth that would have been saved by the rich is spent by the poor, and so that results in a reduction in the capital stock, which shrinks as a result. And so poor households who do not receive the transfer lose from a lower wage rate. Now, I want to emphasize that these results do not fundamentally rely on the preference for wealth. They're actually deeper and broader than the preference for wealth. They fundamentally rely on the empirically relevant fact that the saving rate is strongly increasing in wealth. As long as we have a saving rate that is strongly increasing in wealth, such redistribution of wealth will lead to reduction in the capital stock. I should also emphasize that if we had the standard neoclassical growth model, then the lump sum redistribution of wealth would have no general equilibrium effect whatsoever, because everyone is a permanent income consumer. Therefore, everyone has the same marginal propensity to consume. And so the lump sum redistribution of wealth does not affect the capital stock, does not affect the wage rate or the interest rate. But with a preference for wealth, and with wealth as a luxury good, the saving rate is increasing in wealth. And so when you redistribute wealth from rich to poor, you reduce the capital stock. Now let's focus on a more interesting and a more plausible policy experiment, which is a progressive wealth tax. So let's assume that every year, wealthy households must pay a 2% tax on their wealth above $10 million. The proceeds are transferred to borrowing-constrained households with zero wealth. So that's a redistribution from households with more than $10 million to poor households with zero wealth. Now, the effect of the policy is pretty similar. The general equilibrium effects of the policy are going to be pretty similar as for the wealth levy. The poor are going to increase their consumption. They're going to spend the transfer, so that consumption increases, investment shrinks, therefore the capital stock falls and output contracts. The fall in the capital stock raises the marginal product of capital, which raises the interest rate, and it reduces the marginal product of labor, which reduces the wage rate. Now, the amount of the transfer to the poor shrinks over time. Why? Well, because the tax is pretty successful at deconcentrating wealth, at making the rich less rich, and so the tax base shrinks over time, and as the tax base shrinks, the level of the transfer goes down. And so the right panel is actually quite interesting because it shows the sum of the wage rate and the transfer. The sum of the wage rate and the transfer is the consumption of poor household at the borrowing constraint. So household with zero wealth, the consumption is just the wage rate and the transfer. Now we can see that over the first 40 years, poor households benefit from the policy. Why? Because they benefit from the transfer. But after about 40 years, the amount of the transfer has shrunk, and it has shrunk so much that it does not even compensate for the lower wage rate. And so we end up with future generation of poor workers losing from the policy. And so this shows that there's a trade-off between intragenerational equity and intergenerational equity. In order to reduce wealth inequality at time zero, we end up making future generation of workers worse off. Now, what is the impact of this policy on wealth and consumption inequality? Let us first focus on wealth inequality. So the first row is like the average wealth for the top 1%, the top 10 to 1%, and the bottom 90%. And the bottom row is basically the consumption, the average consumption for the same three categories of people. So let us first focus on the first column, the top 1%. Well, the wealth of the top 1% goes down over time. Why? Because they pay the tax, and on top of that, they respond through intertemporal substitution by raising consumption, which further reduces their wealth. Then let's focus on the bottom 90%. Well, their wealth goes up, but that's such a low wealth level that's not really important. What's important is their consumption, and initially the consumption goes up thanks to the transfer, but eventually it shrinks because of the lower wage rate. What's really interesting is what happens to the top 10 to 1%. Well, their wealth level goes up significantly due to the progressive wealth tax. It goes up from about 1.5 to over $2 million. So why does it go up? Well, it goes up first because these households enjoy a higher interest rate, but on top of that, they respond to the higher interest rate by reducing their consumption in order to further accumulate wealth. And so we end up with this rather surprising conclusion that over the long run, the progressive wealth tax does not benefit the poor. It benefits the property-owning upper middle class. Now, what is the impact of the policy on welfare? Well, as I've already argued, an infinitely lived household should be interpreted as a dynasty. And the social planner should care about future generations. Now, the social planner, of course, cares about the initial generation, and the initial generation is altruistic towards its descendants, towards its children and grandchildren and great-grandchildren. But in addition to that, the planner could directly care about future generation of people. And so the social welfare function should be given by this expression, where W upper bar is the welfare of generation T, and theta is a social discount factor. And so if theta is equal to plus infinity, that means the social planner does not care about future generation, and so the social welfare is equal to the welfare of the initial generation. We only care about future generation because of the altruism of the first generation. The extreme opposite is to assume theta is equal to 0, in which case the planner equally cares about the welfare of all the generations. Here, we take the average over horizon t. In fact, in theory, the horizon should be infinitely large, but we only run the numerical simulation for about 300 years. Now, the welfare of generation T. Well, within each generation, we can either assume a Rawlsian or utilitarian social welfare function. If we assume a Rawlsian social welfare function, then the welfare of the generation T is the welfare of the worst off person of this generation, and that's a person of type N who does not have a preference for wealth and who is borrowing constrained. That's the zero wealth household of type N. The alternative would be to have a utilitarian social welfare function, and that means within each generation, we just take the weighted average of the welfare of all the people alive in this generation. Now, the picture shows the social welfare gain, expressed in consumption equivalent terms, as a function of the social discount rate. Let us first focus on the Rawlsian social welfare function. So if theta is very high, then the planner does not really care about future generation of workers, and so there's a welfare gain from the policy. Why? Because the initial generation gains from the transfer, is better off thanks to the transfer, and we don't really care about future generation. But if the planner becomes more patient and cares more about future generation, then at some point, under a Rawlsian social welfare function, the progressive wealth tax becomes undesirable, creates a social welfare loss. In particular, if we have a Rawlsian planner with theta is equal to 0, which is sometimes known in the literature as a meritocratic Rawlsian benchmark, then we reject the progressive wealth tax. The meritocratic Rawlsian benchmark rejects the progressive wealth tax. Now, under a utilitarian social welfare function, we always have a welfare gain, and this is due to the redistribution from the very rich to the upper middle class, and this is valued by, that is positively valued by a utilitarian social planner. Now, let's finally consider an alternative policy experiment, which is a progressive consumption tax. Why a progressive consumption tax? Before going through the details, I think it's important to explain. The idea is that we're going to target the heirs of wealthy dynasties who have lost the preference for wealth. So if at some point you have some heir that inherit a huge estate, but that has lost the preference for wealth, then we know that this heir is going to squander the family estate, going to spend very big, and we want to target these people. And how do we do that? Through a progressive consumption tax. In particular, more specifically, we consider a 50% tax on consumption above a threshold of $200,000 per year. The proceeds are transferred to the borrowing constraint with zero wealth, as we did before. Just a note to mention that how can we implement a nonlinear consumption tax in practice? Well, that's very simple. You just tax the total income of the household from which all the savings can be deducted. Now, when we implement this progressive consumption tax, well, the main effect is that consumption declines, investment increases, the capital stock increases, output increases, and now the gender equilibrium effects are going to be favorable to the redistribution policy. The interest rate slightly declines and the wage rate slightly increases. The transfer is much more persistent over time because the tax base does not shrink over time. And this policy successfully raises the consumption of the poor, and the sum of the wage rate and the transfer is persistently higher thanks to the redistribution policy. Now, what is the impact of the policy on wealth and consumption inequality? Well, this progressive consumption tax does not affect wealth inequality, but it significantly and persistently reduces consumption inequality. The consumption of the top 1% decreases, and the consumption of the bottom 90% increases. So this policy is successful at redistributing consumption from the rich to the poor. What about the social welfare gain? Well, it's always positive, whatever the social discount factor, and it's even more positive if you're Rawlsian and we care about the poor. Okay, time to conclude. So let me take a step back and think about the conclusion that can be drawn from this analysis. First, how can we accumulate capital if most people do not want to save, if most people are impatient? Well, the answer of the capitalist system is to concentrate wealth in the hands of rich dynasties with a preference for wealth, who, thanks to their large wealth and to their preference for wealth, are going to have a high saving rate, which will allow the capital stock to approach the golden rule level. Conversely, if everyone has a strong propensity to save, such that even with wealth equality, we have a capital stock that is above the golden rule level, then the capitalist system will tend to equalize the wealth across households. Now, it's very important to realize that in a market economy, no one cares about the welfare of future generation of children born of non-altruistic parents. Now, how do we make sure that future generation of children born of non-altruistic parents are going to be born in a prosperous society? Well, the answer is by having greedy billionaires with a preference for wealth who wants to accumulate ever larger fortunes, which raises a capital stock, which enhances the prosperity of future generation of workers, even though this was not part of their intention. And so we argue that this is a significant strengthening of the invisible hand. Finally, we've established that to redistribute from rich to poor household, a progressive consumption tax is preferable to a progressive wealth tax. And this corresponds to the widespread practice, which is somewhat controversial, that reinvested income within firms should not be taxed. Finally, let me just mention that, of course, an extreme concentration of wealth could lead to all sorts of political economy problems that can justify a progressive wealth tax. But that's a very different type of argument, which is well beyond the scope of this analysis. Thank you very much.